temperatures and treacherous weather events make life outside the cities of Arrakis truly hostile.
70 degrees Celsius. This is the surface temperature of Arrakis on a typical day. Imagine living on a planet where a single sip of water is more valuable than gold. Arrakis is so hot and dry that its inhabitants must wear special suits to recycle their body's moisture. Do you think you can survive here? If you are not familiar with the lore of the Dune, Arrakis is the fictional planet from Frank Herbert's Dune series. It is characterized by extreme heat and an almost complete lack of rainfall. This harsh environment has shaped a world of vast desert landscapes where water is the most precious resource.
Only the native tribes known as the Fremen have adapted well enough to survive.
Native Fremen have adapted to these conditions with advanced technologies like steel suits, which reclaim and recycle the body's moisture. But how close is this fictional world to reality? Could such a planet exist in our universe? To answer these questions, we need to break down the science and examine the conditions that could create an Arrakis-like world. While Arrakis may seem like a product of a pure imagination, the recipe for a desert planet is surprisingly simple. You just need high temperatures, barely any surface water, and a disrupted water cycle. First and foremost, we are looking at the scorching temperatures that make even the hottest desert on Earth seem mild. But it is not just about the heat. A true desert planet requires an almost complete absence of surface water and extremely low humidity levels. One crucial factor in creating these conditions is a disrupted hydrological cycle. In Dune, there is a creature called sand trout that locks away water and contributes to the planet's desertification. We don't have sand trout on Earth, thankfully. But we do see similar processes in action. Human activities like unmanaged water extraction for various purposes affect the availability, distribution, and quality of water. These combined impacts can disrupt the natural balance of the hydrological cycle, leading to water shortages, pollution, and ecological degradation. So, what's the result of all this? A landscape that resembles the harsh world of Arrakis. Just like how human activity can turn fertile land into deserts by mismanaging water, a similar process could take place on other planets. The atmosphere plays a vital role in shaping a planet's climate. Arrakis has a higher concentration of ozone in its atmosphere, approximately 0.5%, compared to the Earth's mere 0.0000001%. You may have heard about the ozone being this friendly gas which saves us from harmful UV radiation. While that is true, it also has other properties. Ozone is a potent greenhouse gas. It absorbs infrared radiation emitted from the Earth's surface, contributing to the heat retention in the atmosphere. This shows how even minor differences in atmospheric composition can have significant impacts on a planet's habitability. Now you might be wondering where in the universe we might find the planets with these extreme conditions. That is where the concept of the habitable zone comes in. This zone is often called the Goldilocks zone. This is the region around a star where the conditions could allow for the presence of liquid water on a planet's surface. It is within this zone that we are most likely to find planets with the potential for Earth-like conditions, or in our case, Arrakis-like conditions. Take the TRAPPIST-1 system for example. This system has 7 Earth-sized exoplanets. 4 of these planets are in the habitable zone. However, these planets are likely tidally locked, meaning the same side always faces their star. The side facing the star faces constant sunlight, resulting in extremely hot temperatures, while the opposite side is still in constant darkness and can become freezing cold. This creates extreme temperature gradients that could lead to desert-like conditions on parts of these planets. Another promising candidate is Proxima Centauri b, located in the habitable zone of its host star. Like the TRAPPIST-1 planets, it may be tidally locked. If it has a thick atmosphere, it might support life. However, this same atmosphere could create greenhouse effects that result in scorching Arrakis-like temperatures. These real-world examples may not be exact replicas of Arrakis, but they show us that the conditions necessary for an Arrakis-like planet are not just possible, but they may exist in our own universe. Now let's talk about life. Even in the most extreme environments, life finds a way. From deep sea hydrothermal vents to the driest desert on Earth, organisms have evolved remarkable adaptations. But could life exist on a planet as harsh as Arrakis? On Arrakis, we encounter specialized life forms that have adapted to survive in extreme desert conditions. The most iconic of these are the massive sandworms. While we do not have sandworms on Earth, thankfully again, we do have plenty of examples of organisms that have evolved to survive in desert environments. Take cactus for example. These plants have developed thick, waxy skin to minimize water loss and store water in the tissues for long periods. But what about intelligent life? How could humans possibly survive on a planet where water is so scarce? In the world of Dune, the Fremen have developed an ingenious solution: still suits. These full-body suits are designed to capture sweat and moisture from breath, filtering and recycling it for drinking. While this might sound like pure science fiction, the concept has actually inspired real-world prototypes that utilize heat exchangers to condense moisture from wearers' body. Atmospheric water generators are devices that extract moisture from the air to produce potable water. These machines can operate effectively even in low humidity environments, making them a promising technology for desert habitats. Imagine a future where colonists on desert planet could literally pull water out of thin air. Okay, we may have solved the water problem here, but what about food? Humans need food to survive. When it comes to food production in arid climates, innovative agricultural techniques like hydroponics and aeroponics offer exciting possibilities. Hydroponics, which involves growing plants in nutrient-rich water solutions without soil, can use up to 95% less water than traditional farming methods. Aeroponics takes this concept even further by misting the plant roots with nutrient solutions, typically using even less water than hydroponics, and potentially leading to faster growth rates. These techniques, combined with the development of genetically modified crops designed to tolerate drought and thrive in arid conditions, could potentially enhance agricultural resilience on desert planets. It is not hard to imagine vast, enclosed hydroponic farms providing food for a colony on an Arrakis-like world. While we are developing technologies to survive in harsh environments, scientists are turning their sights to the stars. What if I told you that right now astronomers are actively searching for Arrakis-like planets? The James Webb Space Telescope is at the forefront of this cosmic search. Designed to observe the universe in infrared wavelengths, it is particularly effective for studying exoplanets and their atmospheres. In early 2024, JWST will focus its powerful instruments on the TRAPPIST-1 system, analyzing the atmosphere of its 7 Earth-sized exoplanets to assess their potential for supporting life. Throughout 2024 and 2025, JWST will continue to observe various exoplanets during transits. This process allows scientists to study how starlight filters through planets' atmospheres, revealing crucial information about their composition and potential habitability. But the JWST is not alone in this quest. The European Space Agency is planning 2 missions that will significantly enhance our understanding of exoplanets. Plato, set to launch in 2026, aims to detect Earth-like planets, while Ariel, scheduled for 2029, will conduct surveys of exoplanet atmospheres. These missions will provide us a more comprehensive picture of diverse planetary environments that exist in our universe. However, the search for desert worlds comes with significant challenges. Our current technology, while advanced, still has limitations. Detecting small, rocky planets like Arrakis is much more difficult than finding large gas giants. Moreover, distinguishing between a true desert planet and a barren, lifeless rock requires incredibly precise measurements that push our current capabilities to their limits. The Nancy Grace Roman Space Telescope, set to launch in 2026, will further enhance our understanding of planetary systems and their environments. This mission will contribute significantly to search for Arrakis-like planets. The possibility of Arrakis-like planets in our universe depends on specific environmental conditions: extreme heat, minimal surface water, and low humidity. These factors, combined with unique atmospheric compositions, could create worlds that push the boundaries of habitability. The universe is vast and full of surprises, and our exploration is just the beginning. While talking about full surprises, if you are curious about whether humans could survive on Mars, click here to find out. Thank you for watching.